Okay, today is Friday, 10th of April, and we're going to do this problem. Um, yeah. So I'll just assume that you've read the the thing, and I'm gonna go into my implementation. Okay. So firstly, we have. So okay, I'll go through the first case. So we have. Okay. So one, two. I'm just gonna draw out that grid. 5, 3, 1, 3, 2, 4, 5, 2, 3, 5, 5, 3, 2, 4, 4, 3, 5. Oh, 3, 4. Sorry. Okay. So basically how I thought of this problem was actually I think I got the right idea, but I actually didn't fully get it. So I did have to ask ChatGPT again, but I mean, it makes sense. Okay, so for the algorithm, you'd start from this because obviously, um, the first row will be what is it? It'll be length one, right? So we basically want to keep going through this, right? And like we want to say we're at this position 3, or we're given a query like 3 5. Let's do the second one, 2 5, right? We want to see out of these columns, right? Like this column, that column, if we can reach this fifth row if we start at the second row, right? So how I want to do it, or how I thought of doing it, was that we want to count. We want to have like a DP array, where like let's say, yeah, we want to like, if we're at this position, right, and this number here is greater than this number, the number before it, we want to just add 1 to that, like that index, and that just represents the longest, like we're basically adding to it. So like, yeah, so if we're here, we know above it there's a like a continuous subsequence of 2, size 2, and since 4 is greater than 3, we add to that, so it in turns becomes 3, like a continuous subsequence of 3, size 3, right? So yeah, so of DP, if we're at this column, right, the DP column, this represents basically the longest subsequence. Yeah, so the longest subsequence of that this can achieve, right? And obviously, if it well, not obviously, but if this was, let's say, instead of a 3, let me grab the rubber. Instead of a 3, it was like a 0, then at this point, since this number is not greater than the previous number, we'll have a subsequence of 1, right? So that's basically how you want to do it. And it's also good to note that with the DP array, we actually, for like, let's say we have a query from 2 to 5 again, right? We don't really care. We don't really want to like keep iterating through like this, like these, because we don't want to, we don't need to check this column, then this column, then this column. We can honestly just save like the maximum like subsequence length, right? So okay, so like what I mean by that is, when we get this query, we're gonna check like this row, right, the last row, and we want to see if the subsequence number at this row can reach this. So for it to reach this, it would have to be of length 1, 2, 3, 4, right? But it could also be 5 if it reaches here. So as long as the number stored here is greater than the distance between 2 and 5, which is so 1, 2, 3, 4, right? Then that means it's valid. And after that point, we don't really have to check these other ones, but we also don't need to store the distance of these other ones, because we really only care if one is successful. So we can just be greedy and store the longest one, right? So let me, do I have the VS Code for this? Whoa. Okay, wait. Yeah, let me just put that there. Okay, cool. But then leak anything or something. So what is this problem called? 401 div 2. I think I already wrote the solution for this, so I'll just erase it. Yeah, okay. So yeah. Well, firstly we'll create our grid. So it would be int next it for blank in a range of m, for blank in a range of n. Yeah. So I kind of explain what this does. I honestly don't fully understand it, but I gave something to ChatGPT once, and it said this is like a fast way to do it in Python, but this basically just gets like this, the next number, right? So what we're doing is we're getting like these numbers and then creating it into a row, and then into a row, into a row, blah 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 blah. Okay. And then okay, well, we're gonna have our DP, which will be initially it'll be 1, and there's m columns. Yeah, should we do m or m plus 1? I think m is fine. Okay, and then our max row, I guess, it would be initially it would be 1. Wait, no. Yeah, I think it would be 1. Yeah, okay, cool. I think that makes sense. Yeah, okay. So basically, now we want to iterate through wait, do we even need this grid? I don't think so. I don't think we even need this grid. I think it doesn't matter, but we probably don't need to store it. We don't need to store it, so I guess we won't. So for blank in a range of n, right? So our row, I guess, it's for blank in a range of m. Okay, cool. Okay, so we would probably need a previous row, so prev row equals that, right? And then the new row will be that. Okay, cool, because we got to compare the elements on the previous row. Okay, so if we're at this row, so yeah, I don't think we even need to store this. Actually we would, because we would need to pass it on. Wait, okay, so for I in a range of m, right? If okay, so if our new number at row I is greater or equal, yeah, if it's equal, it's fine. Yeah, greater or equal than the prev row at the exact same index, that means our DP at this index, we just plus 1. But otherwise, if it's less than, we make it, it's not going to continue the previous one, so it has to create a new one, which is 1, right? Okay, and then we'll create our prev row to be the row we just got, and then for our max row, so the max like subsequence, like max continuous subsequence at each row would be just at row would equal the max of our DP, right? Yeah. Okay, and then for, so we have a K equal the next int, right? And then for blank and for I in a range of K, we'll have our A equal right, and B, and they give it to us one index, so we want to make it 0 index for our list, right? And our required length is gonna be b minus a plus 1, right? So yeah, so for 2 4, like 2 5, that's just 1 2 3 4, which is the same as 5 minus 2 plus 1. Yeah. So if our DP at B, so B is like the end of it, right? So if this, the value stored in that is greater or equal than the required length, that means that if we're at 5, if we're at 2 5, right? If we're here, that means the value stored at here can go up 1 2 3 4, or like, or in this case it would be, wait, which one would work here? Oh, this one, it doesn't work, but yeah, let's find one that works. 4 and 5, these two, right? So the value stored at here, this would be 2, because this would be 1, and then at the end we would have 2. So we're saying that we can, there's a like continuous subsequence of 2 at this column, right? And then, wait, no, our max row, yeah. So the max in each row is, if that's true, we print yes. Then otherwise we print no. No. Failed. What did I do? Just greater? No. Okay, wait. Let's print max row. Let's see what went wrong. 2. That doesn't make sense. Oh, so we go 1 and then we go to n. Sorry. I think that should be good now. Yes, yeah. Okay, yeah, so maybe I'll do it in a, maybe I'll make the whole thing. Oh, okay, wait. So this will be 1, 1, 1, 1. 3, that would be 2. That would be 1, because 1 is less than 2. That would be 2, 1. Then this would be 3, 2, 1, 2. And this would be 4, 3, wait, yeah, 2, 1. This would be 1, 1, 3, and 2. So let's say we get 2 and 5, right? 2 and 5. So the max would be this. So this is saying it can only go 1, well, it can go 1, 2, 3 up, right? But we need 4 because we have to reach this. So let's do another example. So 3 and 5, so this and this. So the max would be this, and we can go 1, 2, 3. That leads to a yes. And 1 and 5, for here we can only go up to here, yeah. And you can see why we only need to store the max of each row, because we don't really care about these if this one exists. So I'll submit it. But yeah, that's a good problem. I like that problem. I think it's oh, it already accepted, but submit. Problem C. This one. Boom. I really hope it's right. It's going so slow. I'll give it some time. I swear it didn't run this slow yesterday. I swear it was like instant. Or is it because I'm using the 64-bit version or something? I don't know. I don't really know what. I just know it's faster. Okay, I mean, we can go to the next one. I saw this one like just a bit ago, and once again, I didn't get it right, but I think I was on the right track, I guess. Maybe. Yeah, that's pretty good. Yeah, I'll just let you read this. But yeah, so how you would approach with solving this one is, well, you know that like, okay, like obviously, like this one you have to change, right? So you have 3 and 4 you have to change. Yeah, so I guess like greedily, you wouldn't really want to change this one, because everything so far before this, it was fine, right? You could get through the whole list, so you kind of want to change this one, but you also don't really know which one to change, like what it needs to change to. So it could change to 1, 2, 3, 5, 6, but it just can't be 4. But like, which of these numbers is like the best one to like change it to? So that's kind of how I think of it, right? Um, but yeah, so um, hmm, yeah. Well, um, I do remember the solution, but I don't know if that fully relates to how I was thinking about it. But basically in the solution, it's like at this position, right? Um, wait, so 6, 3. At this position, you could change it to any numbers, like any number you want, or you can keep it the same, right? But oh, I guess you don't just change this one. You kind of can change both. Nah, can you? Uh, I think it's like the solution is actually like kind of like brute forcey in a way, but yeah. Well, at this position, right? Um, you want to try for like for every position in here and every position here. You try all the combinations such that like they don't equal each other or equal 7, and and then you just like save it, right? And then for this one, you kind of do the same. You'd be like, oh, which number? Wait, which number should I keep here, such that the amount of operations the least, right? So we could either like stay at 6, or we can go to 5, go to 4, go to 3, and then like we'll look at this one as well, right? So yeah, I'll code that up, I guess. But I feel like the explanation isn't the best, but I feel like it makes sense in my mind. Like, you kind of like go through each possible scenario and like brute force it in a bit, in a way, but you just use dynamic programming, so you don't have to keep doing all that like repeated work. So I think it was this one, because I cleared it just to make sure. Hello? Okay, it was, yeah. Yeah, okay. So, yeah, so we have t, which is the amount of test cases. I'm just gonna do it this, I'll go back to this and do it the other way. I honestly don't know if this is like better, but so t equals int input blank in the range of t, n equals wait, no, what am I doing? And then you have your nums. Equal a range of n equals, if you have, well, we'll start at 0 because you need 0 operations at the start, right? And then I'll do this by 7 because it just makes indexing a bit easier, I think. Okay. Okay, so for blank, for I don't, would we need this? I don't think so. Yeah, so for blank in a range of n, or 1 to n, because we'll skip the first one, right? Okay. Yeah, okay. So, so for every like previous number in a range of like 1 to 7, right? So for all the possible previous numbers, actually no, it would be, oh, it doesn't, I don't think it fully matters, but does it? Would it? I don't think it would too much. Okay, so like this is like the potential new number that we're gonna have in here, right? So like in the example of 3 and 4, right? 3 and 4, right? We actually I mean, the previous number here doesn't really matter too much, I guess. But like, we're trying to say like, okay, let's consider the example where this is 1, this is 2, this is 3, and this is 4, and this is 5, this is 6, right? Right, so we're also gonna have to do this thing where we switch the like our DPs, because to save space, times 7, and float like when like it's an impossible like scenario, when like let's say the previous number and this new number are the same, or if it adds up to 7, we're just gonna say that as float infinity, because it's just like a really big number. I don't think you have to do that. I think you can just let's see. And so maybe you just have like a really big number like this. But I don't think it will matter too much. Okay. So I guess like the cost, oh wait, no, you would need this, yeah. Okay, so the cost to change to this new number, that would be 0 if the new number equals like the number that it's at right now, right? And then we want to look for each previous number, so prev num, right? Okay, as long as so if new num equals prev num, then we continue, or if new num plus prev num equals 7, then we also continue, right? Otherwise, otherwise our wait yeah otherwise it's chill, and like yeah, otherwise like our new DP at like the new num position, I guess, that would equal the DP at the previous one at prev num, right? Is that how it works? And then plus we gotta, if we needed to change this number to this new num, then the cost would be 1, otherwise it would be 0 if it was already that. And then oh wait, no, it would be max. Oh, it would be the min. Sorry. The min of these two. Right? So then we would, our DP would equal our new DP. And then we would just return the min at this DP. No? Oh wait, print. That should be good. Oh, I remember. Oh, I know. Okay. So it's not 0 because there could be a cost if like, cause like wait, okay, for new num in a range of 1 to 7, if wait, so DP at new num equals this, but it would be num 0. Yeah, okay. Yeah, so basically well, what we're doing here is for all the possible numbers that we can have, right, 1 to 6, right? Yeah, it would cost 0 to not change. Like if this new num is this num, there'll be nothing. But otherwise, you have to change it so it costs 1 operation, right? And then for each for each of these numbers, right, we'll have like a new possible number. So it could be like 1 to 6, right? And if the number at the ith position equals that number, there's no additional operation to change it, right? And then we'll look at each possible like previous number, and if and we want to pick like a pair of a new number and a previous number such that they don't equal each other and they don't add up to 7, and that they yeah, so you have your new number and your prev number such that the amount of operations that you've done if you chose that previous number plus the cost of changing our current number to this new number, we want to find the minimum for all possible numbers 1 to 6. And then with that list of like our DP, we will set it for the next iteration, right? So I'll run through an example, I think. Yeah, so let's say we have so we have four numbers, and it's wait, I'll have a DP where it's 1, 2, 3, 4, 5, 6, 7. Yeah, so 1, 2, 3, 4, 5, 6, 7. Okay, cool. And so we're gonna be looking at right. So we're gonna be looking at the case of 3, 4, 6, 3. Right. Okay. So this is the zero index. I'm just gonna cross it out. Cause yeah. So for the first one, right? This we would need one operation, because if we want our number to be 1 and it's currently at 3, we have to change it, which is an operation. 2, oh wait, no, this would be 1. This would be 0 because it's 3. 4, 5, and 6. Okay, and then for number 4, right? So we've done this, so I'll just cross that out. Right, and we're looking at this number 4 now. Okay, well, like, what number should be in this position, right? So we can either have it as 1, 2, 3, 4, 5, or 6, right? But to change it to 1, it would cost an additional 1, and this would cost an additional 1, 0, 1, 1, right? So this is the number, and then this is the cost associated with changing to that number, right? And then with this number, we want to look at 1, right? So 1 and 1 cannot be, maybe I'll do like, so like that goes to that. So 1, yeah. Okay, so if our new number were to be 1, we can't use 1 because they're equal, right? So it would either be this, 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 or this, and it can't be 6 because 1 plus 6 is 7, right? So it would be out of these. So obviously we'll pick the least one, right, which is 0. So the final cost would be 1, right? If we were to do 2, we can't pick this one, we can't pick this one. So again, we'll pick 0. So the cost of this will be, oh no, it's 1 plus 1, so it would be 2. 3, we can't pick 4, and we can't pick 3. Wait, 1, 2, 3, 4. Yeah, okay. So the cost with this would be 2. Wait, no, oh wait, no, sorry. Wait, this would be 1 because we would pick the 0, right? And this would be 2. And for 4, we can't pick 3. Wait, no, this is 1, 2, 3, 4. 1, 2, 3. Yeah, okay, we can't pick 3. 3, and we can't pick 4. So this would be 2. 2. For 5, we can't pick 2, and we can't pick 5. So we'll pick this 3, which will result in 1. Wait, I did that wrong. Oh wait, no. Wait, yeah, for 4, can't pick this. Can't pick that. Oh yeah, so that would be 2. Okay, cool. And then for 5, we can't pick 2, and we can't pick 2, and we can't pick 5, so this would be 1. For 6, we can't pick 6 or 1, so it's 1. Okay, and then I'll just replace these numbers. Bro. Okay, so 1, 2, 2. Okay, and then I'll rub these ones out too. Yeah, okay. And we have finished this, and now we're on 6. So I'll just hurry this up a bit. So this would be 1, 0. So 1 can't pick 1, 1 can't pick 6. So it'll be 2. 2 can't pick 2, 2 can't pick 4. So it'll be 2. 3 can't pick these two. So it'll be 2, 2. 4 can't pick the same one. So 5 can't pick that. Can't pick 5 and 5, so it'd be 2. And then this can't pick 6, can't pick 1. This would be 1. This would stay 1. Right? And then for 3, the case of 3, it would basically just pick 1. Or it'll pick like 6. And then, wait, I'll just rub it all out. So it's all 2s except the last one. So 2, 2, 2, 2, 2, 1. This would be 1. That would be 3. Wait. Wait, no, that would be, yeah, it would be 3. 2 can't pick this or this, so I'll pick that, so it'll be 2. 2, 2, 2, 5 would be 2, 6 would be, wait, is that right? Wait, no, 3 would be 1, because can't pick these two, you just pick this, plus this, so just 1. The rest would be 2, 2, 2. Something like that. Maybe that'll be 3. Yeah, but, and then you get the min of that, which is this. So that's how you do that one. Yeah, and I'll submit it. See if it's right. Yeah. I really hate this human verification thing because the human verification thing doesn't even work. Like, oh, I don't know. And it accept it. So that's good. And yeah, that'll say, like, look, it says do the human verification thing. It doesn't even exist. So it's whatever. Yeah, I mean, that was the 2 problems that I wanted to do. Yeah, still got a long way to go, all of these. So maybe I'll do this one tomorrow or tonight. But yeah, that's it for today. Okay, bye-bye.